All right, taken care of for the moment anyway. You'll notice I skipped example 3. That's because I'm going to do what I would do in example 3 and example 4, but of course example 4 is the word problem, so it is slightly harder. I would rather show you the harder problem and you do the easier problem on your own than the other way around. So let's look here. It says write an equation and a height. So the height of a thrown ball, the quadratic function of the time it has been in the air. Oh, there's a typo there. I'll try to fix that before I print your notes. The graph of the quadratic function is a parabolic path of the ball, and the vertex is at 120. And the path of the ball includes the point 0, 4. I did fix that one in your notes, but here we are. What is an expression that defines the function? And so we want to write the equation in vertex and in standard. So we're going to cover a couple things here. So vertex form looks like this. You have that written in your notebook already. We know that the vertex is HK, so H comma K is the vertex, which in this one is 1 comma 20. So H is 1, K is 20. I don't know what the stretch is. I don't know if it's normal. I don't know if it's compressed, stretched. I don't know. That's what I've got to figure out. But that other point is going to help me figure that out. So 0, comma 4. So X comma Y is the other point. 0, comma 4. Okay. So 1 squared is 1. And then plus 20. So now I'm going to solve for A. So minus 20 gives me negative 16 equals A. So it does have vertical compression. And so to write that in vertex form, I keep the y and x. So think about like what you type into Desmos. We just keep the y and x. A is negative 16, so it accounts for that reflection there. X minus 1 quantity squared, and then plus 20. So that's our vertex form, okay? And that's everything that this section is about. Pretty simple. Next section, we're going to talk about standard form more, which looks like this. So if I were in vertex form, which is what this is, how could I make it look like standard form? Well, I would just simplify. What does that mean? That means I think of x minus 1 squared as x minus 1 times x minus 1, because it is. And then I'm going to multiply that through. So maybe you learned the words FOIL. Maybe you just learned the distributive property. Maybe you did box method. So if you're used to box method here, by all means do box method as well. So x times x is x squared. X times negative 1 is negative x. Negative 1 times x is negative x. Negative 1 times negative 1 is positive 1. So I'm just simplifying. Okay. Then I'm going to distribute again. So negative 16x squared plus 32x minus 16 plus 20. And last but not least, negative 16 plus 20 is just 4. So this right here is called standard form . And we'll talk more about standard form, but the big idea here is if I went to Desmos and typed this in my calculator and then type this in my calculator, it would be the exact same graph. They're just different forms of the same thing. To shorten the amount of videos here, I'm also going to tell you that this example is very much like that one. So this one is just translated with no types of stretch. And I know that because it just goes up 1 over 1 both ways. That's just a normal stretch there. But it does go left 1 unit, so that's plus. And it goes up 3 units. So I challenge you now to try the multiplying and simplifying like we did here to get down to standard form. Answers will be posted on the next slide.